Okay, here's two good questions. Question says, find the intervals on which the function is increasing and decreasing, and the interval, and the interval on which the function is decreasing. Okay, so I have a quadratic function, so I know it's a parabola. Because this is positive, the parabola is going to go like this. And I have it down here on decimals too that you can see. So they're saying with the parabola, when is it decreasing? And then when is it increasing? And they want to know the intervals this way and this way. Okay, so I want to know, when they're looking for intervals, they want to know the x values. So between what x values is that function decreasing, and between what x values is the function increasing? Okay, those all depend on that point right there and the x value of that point, which is the vertex. So with this function, what I need to do is find the vertex. I can see it here. It's going to be right about there, 6 and something or other. But we can also find it using a number of different tools. Let's use the formula to find it. So to find the x-coordinate of the vertex, minus b over 2a, so minus something over 2 times something. Okay, b is a negative 12, and a is 1. So a minus 12 becomes a positive 12. 2 times 1 is 2. Divide those, comes out to 6. And sure enough, that's what we saw in the graph to be 6. Now, it turns out for this question, that's all you need to know. Typically, we want to find a point for that vertex, that point there. So it's 6 and something. But really, we don't need to find the y value, because I just want to know how far I have to come here before the thing starts turns. Instead of coming down, it starts going up. Okay, so the interval that the function is decreasing is this one. Okay, so it's coming down here. And so the interval, it would start at negative infinity, and it would go all the way up until that point right there, which is 6. So I would say the function is decreasing if you go from negative infinity all the way up to 6. I'm not including 6. Then the function flips. So right here it starts going up. So the function starts increasing, starting at 6, again not including 6, and it increases forever going this way. The bigger the x value you put in, the thing keeps going up and up and up. So from 6 to infinity, that would be the interval that the graph is increasing on. And when you look at the graph that I have here, let me just, whoops. I want to shrink this thing. So if you go right on the axis, you can shrink things, and either way, there. So that point down there, that's our vertex. So everything up until that point, right to that point, the graph is coming down. The red graph is coming down. From negative infinity to 6, it's going down. And then from 6 up to a positive infinity, it's going up. All right, the question, and this is a good one. It says, use substitution to determine whether the given numbers is 0 the polynomial. So what you do is you take this number here, the 2, and you plug that in everywhere you see an x in the function. And then you want to see if it comes out to 0. If it does, then it's a 0. If it doesn't, not a 0. Now, the same thing could be said, like, say, for instance, I say your, the infection rate of a certain virus is defined by this function. So you can say, after 2 days, what would be the number of viruses? So you could take that 2 and plug it in, like I said, wherever there's an x. So I'm going to find the value of the function called g when I plug a 2 in for x. Okay, so it's equal to 8 times 2 cubed plus 2 squared minus 3 times 2 plus 6. So 2 cubed is 8 times 8 is 64. 2 squared is 4. 3 times, this isn't going to work, plus 6. So when you add these, that'll be 68 minus 6 plus 6 is 0. So my answer would be 68. So since it's not 0, since it isn't 0, then 2, that's the number we plugged in, is not a 0. Okay, hopefully that helps you with that. Like I said, I think on the exam I've got a couple questions where they give you a function, and really the only thing you have to do is plug whatever number they have into that function and solve for it and see what you come up with.